So let's start talking about planning Milky Way nightscapes. Hey everyone, this is Mike Shaw with Planit for Photographers, and we're going to cover the basics here in this video tutorial, and then go on to more advanced topics and features of the app in the next Milky Way video tutorial. So to begin, let's open up the Ephemeris Page Chooser, and right here you'll see that you have two tools for planning Milky Way images. They're the Milky Way Center tool and the Milky Way Seeker tool. Both of them relate directly to planning with the Milky Way, but you might also like to know that you will have other options and tools that you can use that relate more indirectly to planning with the Milky Way within the app overall, as you'll find elsewhere. But here in this video, you're going to see how to use the Milky Way Center tool, and that's going to tell you if you want to find out whether or not you can see the Milky Way galactic core region, or in other words, the Milky Way center, on a particular night. And if you've already decided on a Milky Way composition and you mainly want to find out when to take the shot, then you're going to want to use the Milky Way Seeker tool. And those are the main differences between these two tools. And like I said, in this video, we're going to concentrate mainly on the Milky Way Center tool. Now, you'll want to make sure you decide exactly where you want to put your camera first to take your Milky Way image before checking the Milky Way information, since the Milky Way is going to appear at different times for different locations, just like the sunset and sunrise happens at different times for different locations. So as an example, let's suppose we've decided where we want to take our Milky Way photo, say for example from the base camp of Mount Everest in Tibet on May 10th, 2019, right just here. So the first thing to do is to tap the plus button like this, and to set the base camp as the camera location like this. Now that you've done that, the time and the information you now see up here on the Milky Way Center page is specifically for the base camp location on this date. So in other words, for May 10th, 2019, at the base camp of Mount Everest, you can see the Milky Way Center from this time to this time of the next day. And right there, that's super information. And the corresponding elevation angle of the Milky Way Center will range from 0 to this angle right just here, 0 degrees, meaning that the lowest elevation the Milky Way Center will have during this time will be on the horizon, and the highest elevation angle is going to be this angle right just here. And you'll have a corresponding azimuth range from this angle right here to this many degrees. Okay, so that's good to know, but honestly it's a little hard to visualize exactly where the Milky Way is going to be relative to Mount Everest. So to help, let's now look at a couple different ways to view this, and we're going to start by viewing the Milky Way on the map. And first let's go ahead and adjust the time slider until it's night and the Milky Way becomes visible like this. So now that you've done that, you'll see a thick green line on the slider right here. This means that the Milky Way Center is visible, and for this period of time right here that corresponds to the length of the green slider. And you can also see this thick blue line right here, right along the bottom, and you probably already know that this indicates the period of time during which the moon is visible on this date or above the horizon. So from right here, we can see then that there's a crescent moon, you can see right here, above the horizon and visible for the first part of the period of time during which the Milky Way Center is also visible. And you can also see that the moon position on the map, as you can see here, it's over in the west with the Milky Way Center over here to the east. Now we know this because on the map you can see these green dots of different sizes, and the green dots all indicate different parts of the central band of the Milky Way. The lighter ones show the central band of the Milky Way, but they're not the Milky Way Center. That's described by the biggest green dots right just here over here. And these represent the actual Milky Way Center, and the bigger dots represent the section of the central band that's near the Milky Way Center. So the biggest green dot is the galactic core. Now this region of the central band near the Milky Way Center is much brighter and often more sought after than the non-central part of the Milky Way band. So you can consider, in other words, the Milky Way, the whole Milky Way Center, to run from all the way up here, all over to here, and also in fact underneath the Earth, and that we can't see it because the Milky Way is actually like a belt that goes around the whole Earth, and we'll talk more about that in a minute. Now you can also see several lines coming out of the camera location that are useful. This line right here points to the Milky Way Center at this azimuth right here. And this line right over here corresponds to the highest point of the Milky Way arch, something you might want to know when you're planning a panorama, for example. And these two lines on either side correspond to the two ends of the Milky Way arch. So with the help of all these different lines, you can really see and plan the whole arch direction and how it's relative to different ground subjects. And while you can visualize in your mind what the arch looks like, it can be a little bit tricky. So one thing you can do with a map is to tilt it like this. and even rotate the map like this. Tilting and rotating the map can really help make it easier to imagine the position and the orientation of the Milky Way arch compared to the flat map. Now I gotta say, even this is still not the best way to visualize the position of the Milky Way. We also have the virtual viewfinder feature. And I'd say I spend a vast proportion of my time with Planit using the virtual viewfinder. It's so useful for so many different things. I just love it. So let's point the camera to the Milky Way center by rotating this green line like this. And then we're going to select the VR viewfinder right over here, and boom, here you go. Let's go ahead and select a wider angle focal length, such as 14 millimeters. And now you can have a much better idea what the Milky Way looks like. And I'm sure you'll agree that it's much easier to visualize it this way. On the map view, it can be a little difficult to imagine the relative position of the Milky Way and the mountain. And with the virtual viewfinder, it's much easier. This tiny peak is actually Mount Everest. There are some much lower mountains on the left, but since they're closer to the camera location, they appear much bigger just from perspective. Okay, so now let's adjust the time slider and notice the Milky Way movement. The Milky Way center slowly rises like this. And now let's go ahead and switch to a 35 millimeter focal length lens. And that'll allow us to see it more clearly. And this way we can capture a bigger, relatively speaking, Mount Everest and the Milky Way at the same time. Now you can see that as we adjust the time, we can see the Milky Way goes out of the frame. And in this case, we'd need a wider angle lens, such as a 24 millimeters. And as we continue adjusting the time slider, eventually the 24 millimeter isn't enough, and we need to switch to a 14 millimeter wide angle lens. So this right here is what your view would look like with a 14 millimeter focal length lens at this time right here. This is Mount Everest. So as you just saw, by pre-visualizing our scene in the virtual viewfinder from our chosen spot at Mount Everest Base Camp in Tibet, we can pretty much decide what focal length lens to use, what kind of composition we like, and at what time for our chosen date. All right, so now look at this. We can also check out the moon right over here. Now the crescent moon was still up at the beginning, so at this composition the moon can light up the mountains so they won't be too dark. It's even possible that for a very short period of time when the moon is about to set, the moonlight will light up the Mount Everest in a red color. And that's because moonlight is simply reflected sunlight, so if it shines on something from a very low angle above the horizon, it'll act just like sunlight and light up the mountain in a red color, just like at sunset, just dimmer since it's the moon. So now, wouldn't it be cool to have a red Mount Everest peak with a Milky Way center just above it? Framing it with a 35 millimeter lens should be a great choice. And then, after the Milky Way center rises for a while, we can switch to a wider lens to capture both the mountain and the Milky Way with more sky. So like you can see, even when we're at home, we can plan exactly months in advance and in a location that's thousands of miles away at over 17,000 feet elevation. You can even know how long we're going to stay out shooting and what focal length lens to use. These are all tremendous advantages of pre-planning. So until next time, this is Mike Shaw with Planit for Photographers saying thanks for watching, and we hope you enjoy planning your Milky Way shots with Planit.